Thanks for joining. We are going to go over how to configure the Ford Pulse Width Modulated IAC valve. We're going to go through how I do it for the SNs, SN95. Donny here from Anderson Ford is going to help out, talk about his process a little bit on how he does the 86 to 93s. This is not a debate on what IAC is better. This is just how we have handled how to do the Ford 2-pin idle air control valve on setting them up. I'm going to let you introduce yourself real quick, Donnie.
Absolutely. Okay. Yes, everyone. My name is Donny, and I'm with Anderson Ford Motorsport. People probably know me from YouTube as Donny B. Very simple. And like Danny said, we're going to talk about Ford Pulse Width Modulated Idle Air Control Motors. Super awesome stuff. Super interesting stuff.
I'm Danny. I'm over with MF Customs. By now, some people know me. If not, that's okay. We're going to try to do some configuration in the Holley software. But first, we just want to walk through how I've done this. I made a really good post on this on the Ford Holley group on Facebook. And tonight, and a lot of people have asked us to do a video on it. So here we are. I do want to stress one piece is idle should be near the last thing you try to attempt to set up. You need your fuel tables done. You need your acceleration enrichment stuff all configured out. You will want pretty much your entire tune done and in really good working order before you go working on idle. And the reason being is if any of those are off, your idle's going to be off. So what I usually recommend, and Donnie, I'll let you speak up after this, is I usually try to set the car about 950 with the throttle blade to 1,000, just a high RPM, something that I don't really need an idle air control valve to get the car to run and drive, and then start doing my tuning, and then come back and bring it back. What's been the steps you've done?
Very similar, and I think that's an important point to stress in regards to getting your fueling and getting your basic overall tune functionality dialed in or close to dialed in as possible. Give or take. You don't want to sit there and spend hours trying to get it at 0% on any closed loop settings or anything like that. But I'd say probably a good rule of thumb, if it's within between I don't know, what'd you say, 3 and 4%, that means you're pretty darn close. And depending on the weather and stuff, that may change, but it's got to be close. And so, like Danny mentioned, I do the same steps. If the car starts and runs well enough to do the static timing, or as I like to call it, the locked timing check. So that way, everything you're doing is not all for nothing. Once you get that locked in, and you know that the timing is synced in with your Terminator X or HP or Dominator, or whichever Holley ECU, I think this is across all spectrums of the Holley EFI ECUs. Once you do that and you start actually getting your fuel idle table or fuel table at idle and stuff and driving really close to being 100%, then yeah, go back and then change it. And then what I like to do in regards to the idle air control motor, and again, all being this whole conversation's about the Ford Pulse Width Modulated idle air control motor, is I like to do the same thing. I like to have the car idle higher than I want my ending idle speed to be at, and then get the fuel table dialed in, because again, I don't want it to be swinging on me because it's constantly trying to hold the lower idle, where when a finished tune is done, I don't want that to be constantly fighting against me. And then another thing I'll do is I'll actually unplug the idle air control motor and stuff after I get it set and make sure that it actually still holds idle, to verify that the idle air control valve is working. And usually you can tell if it's working properly or not, because as soon as you unplug it, you might hear a difference in the vehicle, how it runs. Now, if it's plugged in and you unplug it and there's no change, that might be caused for kind of nail those two birds at the same time, verify that it's working, and then also that it's actually holding the idle that that I'm actually setting the screw at, and then plugging it back in, and then changing the screw from there to get the percentage to where the motor is not working so hard, or if it's working too hard to adjust accordingly.
One of the key things I try to do also is when I do, and we'll get into it here shortly, is the manual, when you do read it, if you've read it, Holley usually recommends between a 0 to 10% IAC setting. And that is not the case for Fords with the two wire. That is perfect for LS or a stepper style, but we're not going to be working on that in this video. So keep that in mind. That is mainly meant for the Chrysler or the GM style stepper motors. The IAC isn't linear.
Yeah, that's 100% true. And then that brings up another point. The reason why we probably need to show this on the software, just a point here is that the 3.5-inch touchscreen cannot make these adjustments. Even if you select 5-liter Ford from your touchscreen monitor, it will not switch it. And I think, Danny, you made a point off air here in regards to why it won't switch. It's because you got to go select it on the pin map. So, more reason to, like, for people wanting to dial in their idle and stuff using the Ford IAC. You'll want to download the software and do that portion of the tuning that way. Absolutely. So yeah, fantastic.
The 3.5-inch screen is super handy. It's just you have to remember it's not a tuning device. It's a monitoring device. You can build a tune with the wizard, but it's not meant to go in and do fuel corrections or anything like that. You do really need a laptop. I recommend the USB to CAN cable, but I have known some people that just work strictly with the SD card, where they pop the SD card out, go into the house, use their home PC, make tune changes, then take it back out to the car and go back and forth. That's a slower process. With the USB to CAN, you can make live changes,
right?
Which is very important. And to really get something dialed in any car, it's best to be able to do live changes. But it's you can work around it. It's just a much slower process.
And I think that really helps out for people, like, especially if you're not even going to tune your own vehicle. For example, say you just need to get your car up and running, get it on a trailer, take it to a facility so they can dial it in for you. You still need to get your base file into the ECU, right? Going to the laptop, or like Danny said, your home PC is still a vital, part of this whole process, especially dealing with the OEM Ford stuff.
We're going to do in the air quotations here of, we're going to pretend that we have our tune pretty much dialed in. We're sitting at, about 5% correction. Donnie, you brought it up, don't shoot for getting that down to 0. I mean, we're coming into fall now, and you're going to see those changes. You might have had it down to 5%, and now it's getting colder, so it's going to add more. So, you might be sitting at 6 or 7%. Don't, go for a 0. It's just not going to happen. You can get it to happen once, 20 minutes later, try to get it again, and it's going to be changed just because of temperature changes and stuff. Get it dialed in as close as possible. I shoot for a 5. 5% is usually what I go for. But let's say we have everything dialed in, and now we want to work on idle. First, we need to do some physical pieces. And those physical pieces will be adjusting on your 86 to 93 Fox bodies, the idle screw. 94, 95s, depending on the throttle body you have, it does not have a throttle stop screw that's adjustable. 94, 95 actually had a IAC bleed valve that you could adjust, and that is what you'll use on those. If you have a BBK throttle body, you might have some whistling, and you may run into some issues there. Not all, but some of those do cause problems when it comes down to idle, so keep that in mind. So, okay, we got your car ready. First thing you want to do is just get it going, start it up, get it up to temperature. I shoot for about 180. And what you want to be able to do is get the car to idle on its own at temp with no interaction. And once you're at that point, the first thing we do is we disconnect the idle air control valve, and then we start adjusting the throttle blade screw on a Fox. And we usually shoot for 50 RPM lower than target. And that might get a little difficult when you get down to that. So if you got a big cam and
Yeah,
you're
especially
shooting
a
for
little camshaft. Yeah.
750, it may not happen. So
Hmm.
be realistic on your RPMs too.
Yeah, I was just saying, depending on the camshaft, like you just said, be realistic. If you got, for example, an N41 cam and you're trying to idle, say at 700 RPM, and you want to bring it down to like 600, it might kind of slobber on itself a little bit. It might have a hard time, choking down enough air to keep it running. So just be realistic in regards to what your idle's going to be.
Stock cams you can get away with about a 750, 800. Anything aftermarket, I usually start at 850 and work my way up depending on how aggressive it is. So in this scenario, we're going to say we have an Anderson cam and we're going to go for 850. So
Perfect.
what I would shoot for is start adjusting that throttle blade down until I get to 850 and then shoot for a little under. And that might require a little interaction, but you don't want to be opening the throttle blade a whole lot. You're just going to do your best to keep it running. Once you've done that, you're going to turn the car off. You're going to turn the ignition back on, and you're going to do a TPS Auto Set. And to do a TPS Auto Set, I'm going to switch over to the software here, is you're going to, in the software, you just click on the drop down near the sync, and there's a TPS Auto Set, or Control T is the shortcut. You will follow that process. You'll push the throttle pedal down to the floor and back up slowly twice until you're done. It should give you a successful. The reason you have to do this is because you have messed with the throttle blade, which will also change your voltage on the TPS insert.
Yeah, the whole throttle position will be changed. And anytime you make an adjustment to your throttle blade, you have to go in and do a TPS auto set.
So now we have the TPS Auto Set done. Before you start the car back up, let's plug the IAC in and start the car. We haven't done any settings yet in the Holley for the Ford idle air control valve, but we're just going to go ahead and plug it in so we can get started. Once you start the car back up, it should idle on its own because that was the goal. The goal is a warm idle with little to no interaction from the idle air control valve. And now we're going to go through the software and I will walk through how we do it. Just remember, these are base settings that we start out with, and you will have to adjust accordingly. So the first things we do is we come into the software, we click on the idle ICF, we make sure idle spark is enabled. I typically change the P term to an 80, and I leave the D term to 60. This seems to be a Ford thing on the PWM. I'm still investigating this one, but this seems to work for us. Frequency anywhere between 300 and 315. It is important that you have your IAC type set to PWM. For the hold position, I typically start out between 40 to 42%, and I will walk through the process of where to get that number from in a little bit. And everything else in this area, we will fine tune later, but we'll go through what they do. Next, we'll go to the IAC park position. Holley's default is like 100%, and then it drops down. As you can see, I've already got this somewhat configured. 42% when it's warm, and cold, I started out at 70. These can adjust, and that'll be the part I'll walk you through on how to find out what that might look like, and you can adjust accordingly. And that's really the only things we'll be changing. Once you got this set up, you will click on the sync with ECU. We're going to send it over to the ECU. Yes, I'm actually connected to an ECU. And now, because it's live, I've actually sent those changes over to the ECU, and the car should start acting a little different. It should be attempting to idle the way it is, the way we want it to. Now, let's go back into the IAC settings. What we want to do is find our hold position and our RPM above idle to start ramp. Donnie, how do you interpret the above idle to start ramp?
My thoughts of this have changed because, well, let me rephrase that. It's changed over time because originally I thought that the consensus was it is the idle RPM, that number plus the number of RPM you want it to reactivate to start the actual ramp down.
Mhm.
So I used to put these at like 1750 or 1500, depending on what it is. So I've changed that now to where it's actually where I believe it's the percent or the RPM above your target idle speed that it actually turns the ramp down settings on to go on the ramp down.
Yep.
I hope that makes sense.
Yeah. So what Donnie's talking about is, you have your idle speed in this, and we're going to change this over to 850 because we picked Donnie's cam, and we'll leave the rest be. That will be the RPM. How I've looked at it is I have the idle speed set at 850 and I got the above to start the ramp at 250. So 250 plus 850, quick math, is 1100. So at 1100 RPM is when it's going to try to catch the idle. So dropping RPM down to idle, it's going to try to catch it and then begin the ramp down the rest of the way. I usually bring these up to, on an automatic car, I usually set it about 500 to 550-ish higher. And on a manual car, I might even go as high as 750. And the reason being, on an automatic car, you're not just driving down the road, popping it into neutral for the engine to rev down. The automatic transmission is going to keep the car at a specific RPM as it comes down because it's basically an engine brake. But owners of manual transmissions might just push in the clutch, and what's going to happen is your RPM is just going to flop right down. There's nothing to catch it. So I shoot for a higher RPM for this way to catch it, and then slowly start to bring that back down. That can be tricky. Ford's factory ECU does a really good job at catching that. Holley's logic isn't 100% there for all that. You could do some advanced tables and all that, but we're not going to go that far in that.
It's not really necessary, I don't think. That was another thing, is that a lot of people thought that you had to do advanced tables to make it function properly. And I don't think that's the case anymore. Just having the understanding of how this works properly, then you'll actually won't need any advanced tables, at least in my experience.
Yeah, I've only had to do an advanced table on maybe 2 cars at this point, and that was just for more of a drivability issue, and the cam was well over 600 lift. So it was pretty radical, very little vacuum. So it was special use cases. I prefer, and Donnie, this is up to you, I would like your opinion is too. I prefer a longer decay. So I prefer a slower drop down to my idle speed versus a quick 2-second drop. How do you prefer yours?
I don't want it to hang, but yes, I don't want it to like fall so fast that it's physically impossible for the valve to catch any kind of possible stall issue, because it's worse stalling than it is hanging. So yeah, I'm more like in the middle. I want it to drop, but I don't want it to hang either.
Okay. Yeah, I usually shoot for between 3 and 4 seconds on mine.
Yeah, that's fair.
The IAC hold position, we're going to get into that now. That is where you're driving down the road and the idle air control valve is opened up to a specific point in preparation for you to go back to an idle. What we want to do is we want to find out what that magical number should be. And what we're going to do is we're going to use the idle speed to find it. So in our scenario, we'll go into idle speed. And I think you've done some of this with Matt from Leach Motorsports from back in the day on one of your cars. And what you'll do is you'll just take your idle here and you'll just start jumping this up. So, you'll throw it at 1,000. You'll come down. My idle air control valve positioning won't change. But in your car, if you're doing this live, you will see that values start to change. And you'll want to write them down. And I like to go all the way to 1,800. And I do it in 100 RPM increments. Now I'm going to go like 1,100, write down that number, repeat that up to 1,800. And then I'll throw this back down to my 850 range. And what I'm looking for is, I'm going to look at my data that I wrote down, and if I set, because we're playing simple math here, at 1,100 RPM, I'm going to be looking at what was my IAC position at 1,100. And that is going to be my start point for the hold position.
Yes.
Is that how you find it, Donnie?
Yeah, that actually is a better idea. I haven't done it like that. I guess I'm a little more impatient, especially working on my own cars. But that makes sense. Usually I would just raise it up like another 500 or so RPM, but it makes more sense to do it in 100 RPM increments, just because then you could really fine tune and see the number. So that's a really good way to do it. It doesn't really take that much longer to do it that way. So I haven't, but I think that's going to be a new practice for me.
Yeah, so I do it that way because I want the data, because I want to make sure also I'm not going to overshoot. Because what will happen is if you put your hold position too high, when you're coming off of cruise and going into idle and your IAC is set too high, you now have cruise control because it's going to catch it up too high, and you'll come up to a stoplight and you might be revving at 3,000 RPM because the engine can't come down because the IAC caught it too soon. So if you got like 72% here in your IAC hold position, you're just way too high. This should be somewhere between 40 to 50%, that 10% range. Now that's going to depend on your idle air control valve. Ford did use multiple different versions. We're not going to get into that detail tonight, but a good safe number is somewhere between 40 and 50%. Then what you'll do is when you have that, you'll come back to your park settings and you will set your park setting just, so let's say we found the hold position for us was 42%. I come in and I change my park position just 2% higher at running temp, and then I blend it across the rest of the table. And that'll give us a nice, slow, gradual at different temperature ranges. One thing you need to know is the Ford idle air control valve, if you have it at 100% when it's really cold, it's going to do nothing. Max out's usually somewhere between 80 and 92%. Again, this goes back to which one do you have. You could find that if you really wanted to by increasing your idle speed, but I don't think anybody in your neighborhood or wherever you live wants to listen to your car sitting there revving at 4,000 RPMs or whatever, whatever it'll actually do. So keep that in mind. So Donnie, now we've gone through, we've gotten the basics installed. We have our very bare minimum in here. We found some of our stuff. What is the next steps that you typically do?
Yep, we already talked about idle spark. And yes, I do the same thing with the P term. I turn it at 80. The IAC control, we already went over that. The ramp down and stuff, very important. I'd say we did talk about like that the ramp speed coming down, and that we like 4 seconds as like a good moderator, I guess you could say, a middle ground, and stuff like that. So yeah, there you go. Just pointed it out there. And then also the RPM above idle to re-enable idle control. That one I think gets confused a little bit in regards to like, why is that even there? Because it's actually activating above like that number above it. So I think we should actually touch base on that a little bit about what that actually means. The RPM above the idle to re-enable the idle control.
Go for it. You brought it up.
Okay. And also like, the ramp decay time. Yeah. Like Danny said, if you found the sweet spot at 42 seconds, and based on how fast you want it to come down and stuff, you would change that number accordingly. I'm trying to figure out the best way to word this, because I don't want to make it sound like it's the same thing. The RPM above idle to start the ramp, and then the RPM above to re-enable idle control. I guess in the name itself, if some of this stuff doesn't make sense, Holley does have definitions on their website that actually like talks about every single one of these. Like they have like a glossary or like a whole dictionary on this whole thing of what each individual parameter means. And oh yeah, you're bringing it up.
I don't know if people, I want to bring that one up, is if you look at the top, there's a help with a question mark. Whichever page you're on, or whichever area in the software you're at, if you click on that, it's going to take you right to the manual to that part. So you don't have to go searching. It takes you straight there. And then you have all of your information.
The key I want to like really point out is that, and we kind of touched about it, because even I mentioned it, of what I do. Sometimes I take drastic steps and I jump 500 RPM increments. And I think the key is that when you start changing these settings and stuff, it might be best for the user not to change everything so rapidly, because that could throw everything off. You don't know what you're doing is helping or hurting. So the whole steps there, doing the IAC ramp down, regards to percentage, and doing the through the idle test, through the idle speed section of the software and stuff, you may not even want to touch that number yet, unless like it's not catching quick enough or something for you.
Yeah.
So at that point, see how it's only got a 50 RPM, as its default setting. Maybe raise that to 100. Don't raise it like 200 or 300 or 500. I just say just be incremental and about what you're changing. So that way, like if you do make a change on something so small like this, that that if it made a good change or not. And that way you don't have to wildly swing back and forth. It's like, oh, okay, so it actually caught quicker, and now it doesn't have a chance of stalling or swinging down so far that the idle air motor pops a lot of air all of a sudden, wildly swings the idle back up and comes back down, and therefore maybe only change it another 50 RPM and maybe it catches it a little bit quicker and stuff. So I think people might get caught up in the definitions, and I kind of messed up by saying that. Well, what does this mean? I think what it is that if you don't want to get into all the definitions and go to the help button and see all the definitions, make minimal changes so that way you don't drastically throw off your tune, because you may have made some really good headway in regards to your idle and what it can do on the ramp down. And then if you start making wild changes, it may throw it off, and you may think that the thing that you already dialed in is part of the problem, and you change that along with what you may already change. So I would just say that what I like to do, I have my basics, right? And what I like to do is very similar to this, and then use that as my starting point. And then, but if you're starting it for the first time, you may not have all these settings, but if you do make some changes, just don't make them so drastically
Yep.
and or wildly inconsistent in the numbers and stuff like that. So that's what I really wanted to point out. Because yeah, there'll be some options on here, even though they seem like they're pretty simple. There's not a lot of boxes here. But in regards to the Ford stuff, this, like Danny mentioned earlier, the logic for it was not built for Ford. I mean, let's just call a spade a spade. Holley's bread and butter is GM, and the Ford stuff was kind of an afterthought. And so we're kind of band-aiding this to make it work. But if you take your time with it and do incremental changes and stuff, you could get it to run extremely well.
Yeah.
That's what I wanted to point out.
And I'm going to give my definition of what that does really quick. That is basically how many RPM above your idle. So if we're at 850, 50 RPM would be 900 RPM plus, I think TPS has got to be 1 or 2%. It's going to move the IAC back up to 42% in this scenario. So if you have a big canvas swinging back and forth,
right,
you'll want to up that some. But that's how I've seen it in the software behave.
Yeah, and that's why, and I'm glad you said that, because that just reminded me why I brought it up in the first place. It's because of an issue I'm actually having with one of my cars currently. And we've actually seen this issue come up on the forums a couple times, where people will complain that their cars out of nowhere will start idling at like 3,000 RPM and hold it. And what Dana just mentioned, if the throttle position all of a sudden is showing 1%, 2% right off of idle, like if it's not at zero, all of a sudden it's probably going to try and find that RPM at that hold position. And because it's activating it right above throttle position 0, it's at 1. So randomly, my car just all of a sudden started idling at 3,000 RPM. And this is the red car. This is the Project Everyman car that's dialed in and runs fantastic, but just all of a sudden had this issue. And freaked me out, because I was coming to a stoplight, and people probably wondering why I'm revving my car at 3,000 RPM. I noticed my throttle position was showing 1%. And then, Danny reiterated to me that, hey, if it's at 1%, guess what? It's not idle anymore. It's thinking you're actually got your foot on the gas and you're starting to go. So it's going to go past that, whatever your hold position, whatever your idle setup is, it's not idle anymore. That's something, if you're experiencing an issue like that, take a look at your throttle position and see if it's actually showing like 1 or showing past 0. Because if so, then you could have a faulty TPS sensor or something else going on. So that's the whole reason I wanted to bring that up. Thank you for bringing that. Just made me think of it.
Yeah, but that really in the end is where you're at, right? Like there's no magic to it. The Mega Squirt, folks have been running the 2-wire PWM modules for decades, not just years, but decades, with no issue. A lot of European cars, smaller cars, came that way as well. They came with the 2-wire, so it's a good IAC. It's just it's very fast moving, so you have to be prepared for that, and that's kind of where the Holley software is a little lacking on that. That's why I kind of like my hold position or my decay rate, my ramp decay time to be a little longer, so I know how it's going to react versus what Holley wants it to do. I mean, yes, Holley's doing the 4 seconds of decay, but I don't think the Holley's back end controls that we can't get to can handle the fast decay of a PWM module. So a slower doesn't have to be like 5, 6, 7, 8 seconds. 4 seconds is pretty about max is what I do. 3 to 4 is normal. Just so it gets that nice comes down and you're done. My startup,
Hmm.
which we didn't really get into these, is the startup hold is, when you first key it on, it brings it up, holds it there for X amount of seconds. In this case, we have in the software 4 seconds, and then it decays it for 4 seconds. So that's 8 total seconds. What I recommend folks to do is once you get all this stuff configured, do some hot starts and change these around a little bit. And maybe start out with a hold time of 2.5 and 2.5. Switch these out. I'm going to switch them right now. Start out there and see how it reacts. Go drive the car, get fuel, get a sandwich, turn it off. Is it behaving the way you want? Great. But the real key thing is take it home, park it, don't touch it for a full day, cold start it. What you might see is it might require a little bit more decay, or it might require a little bit more hold before it comes down. Now it's not going to drop down to the 850. It's going to drop down to what we have set for an idle speed for that temperature. So if it's a 60-degree day, it's going to sit at 1100 per this. It's going to interpolate, but about 1100 RPM, and then slowly start coming down. It'll bring the RPM down over that. Keep that in mind. So you might have to mess with the target idle when it's cooler and on a cold start, and you might have to change your hold and decay rates when it's colder. Have you ran into any of those issues?
I've on a couple customer cars I have. I know with Project Everyman, we pretty much got that almost spot on once we figured out where the sweet spot was for the idle air control ramp down hold percentage was.
Mhm.
And after that, and then of course we had the fuel table dialed in again, a very key point. Once we had the fuel table dialed in, that cold starts and stuff are pretty much almost 100% spot on. I would say that with the colder temperatures and stuff, I haven't really had a chance to test it because I normally don't drive my cars in really cold weather. We got really close with that one. Now my turbo car is a different story. That one I kind of started over from scratch based on the new stuff I learned. Now, guys, this has been a big learning process for me as well because having more people that know a lot about stuff. I'm an open book. I like to learn a lot of stuff, so that's kind of why I'm here, based on what I've learned and also what I'm continuing to learn. But with my turbo car, it's a little different. Like for example, I'm probably going to take some of the whole 100 RPM steps in regards to finding the perfect or the proper hold percentage. I'm probably going to take that and actually take it to my turbo cars because the problem with that car is that on cold starts up great. It'll probably surge for a half a second. It'll pop that air at the initial start. It'll pop up, come down, swing past the cold idle, which is normally for me like around 1100. It'll probably swing down to about 900, maybe 850, and then swing back up to 1100, and then it'll kind of just dance in that little spot for a little, like I said, a half second. But on hot starts, I've noticed that recently it's been having a hard time starting. Usually takes me two full like cranking cycles, and then they'll actually hold idle. So that's stuff I need to actually do. And even though my fuel table is pretty darn close to being dialed in, I still need to go through and get that proper park position for that. And also, like Danny said, I haven't really had a chance to really mess with that for that car at least, the startup hold position, or sorry, not hold position, but the startup decay and the startup hold.
Mhm.
And so I haven't really messed with that time. I just kind of left it because I figured it was good at when it was cold. But now when I'm noticing an issue when it's warm, so I may not have an issue when it's cold, but I need to mess with that setting still. So yeah, I still have some work to do on the turbo car, but I got lucky with the red car and stuff that it once we get that fuel table dialed in and got those positions right during cold or hot, it seems to start up and on the first fire, find its idle pretty darn quick, and it doesn't have a wild surge or a wild swing of any sort. And when I push the clutch pedal in coming to a stop, it usually just it comes down kind of rapidly, but then it kind of like slows down towards the end, and then it never swings down. It just hits right at the idle spot. So we just happen to find the right spots for that through just a dyno session.
Some cars are easier than others. I mean, some of them I can do in an hour, and some of them make me want to rethink my life choices. So
Hmm.
don't give up is key. I think we're just going to kind of end it there. This is just a high overview. If you are interested in us getting into detail and doing maybe some live data and simulating an engine running, we can do that. Just leave a comment. If you have questions or anything else, leave them in the comments and we will do our best to get back to you on those. Donnie, you got anything else you want to say before we stop?
Just to reiterate, this is what I think a good starting point is for people, because the last thing I want people to do is take these settings and all of a sudden their car not run right, and then
Yep.
you know think that these were not the proper steps to take. These are great starting points because, like Danny said, every car is different. For example, if I were to import my settings, and granted, I have OEM Ford idle air control motors on both my Fox bodies, and if I were to put the same percentages, same everything from actually, Danny, could you go back to the idle ICF?
Absolutely.
So if I were to set both cars up at the for the exact same setting and say they had the same displacement, same fuel injector and stuff, the turbo car just won't run the same like my 93 does, my supercharged car. They just don't, because again, it's gonna be a little bit different. The amount of frequency going through that idle air control motor may be just a hair different, even though they're both OEM Ford. So yeah, these are great starting points, and that's what I think that really needs to be pushed here. Is that these settings that we put in here are ideally, if you start here, you're on the right path. Once you start changing a couple little things here and there, you'll probably notice a huge difference. Minus the fuel table. Again, we started with the preface that you've already done your fuel tuning for the most part, and now you're just wanting to get your idle and your ramp down and stuff to avoid wild idle swings and stalling and stuff like that. So I think that we really wanted to just put out here that these are great starting points. And again, Danny did this as a write up. I think in video form, showing people
Yep.
that the reason why we would do these as starting points. Like for all my base tune files and stuff, I may do something a little bit different in regards to like because I send the base tune files out from Anderson Ford Motorsport, and these settings might be a little different just based on like what I've seen from other vehicles and stuff. Because we've done a lot of Holley EFI tuning, specifically Terminator X box body, so there might be something that I've seen that worked pretty well for certain combos. But again, if it's not something that your car likes or you like, I'd say this is a fantastic starting point. This is like, again, not the holy grail or end all be all, but I think that if you're looking to get into it and you want to start dialing it in yourself, having a starting point like this will definitely get you in the right direction. That's why I really wanted to point out.
Absolutely. So, with that said, there's going to be multiple videos out there on YouTube or any of the platforms stating how to do it. And I'm not saying any of those are wrong. I'm not saying ours is right. It's just how we do it, and we wanted to put it out there. I wrote a documentation out there. People have asked for a video, and here it is. We'll go from there. I will take the feedback from folks, and if we need to do more, we can do more in depth stuff. Just ask, and we will take it back and see what we can do.
Absolutely.
All right.